Okay, so adding and subtracting fractions in general, harder, because you need a common denominator. So that's a little bit annoying. Not as much with monomials. Can we agree that these are all monomials? But when we get down here and they're polynomials, it just becomes a little bit uglier. So you got to be patient and clean and organized with this. So if you're trying to get a common denominator here, because you have to add fractions, what is that common denominator going to be? Say it again. 12x, right? The x is already there. So we just need to turn 4x into 12x, multiplying it by 3. And remind me, why do I have to multiply by 3 over 3? Because that's the same as multiplying by 1, and it will change the appearance, but it won't change the value. And then 6x to become 12x needs to be multiplied by 2 and 2. So there's some distribution that has to happen up top. 3 times 2x minus 5 is 6x minus 15 over 12x. Plus 4x plus 2 times 2 is 8x plus 4 over 12x. And now when I'm adding two fractions, my numerators have to be added. So what will my numerator be, Angie? Why negative 2x? Did you do 6 minus 8? Yep. So minus 11. And is that your final answer for the whole problem? What else would you add on to this? All over 12x, yes? Very good. Okay? Any questions on that? If something is factorable at this stage, you would want to try to factor it to see if it will cancel further, but 14x minus 11, there's no common factor. Okay? Over here in B, what would need to be the least common denominator here? 10x, right? So this one just needs to be multiplied by 2. And this one needs to be multiplied by just x, yes. So my numerator here becomes 8x minus 2. My numerator here becomes what? X squared plus 5x over 10x. So when I add these fractions, I should do the numerator in the proper format. So my x squared term is going to come first. Combine my x's, 8 plus 5 is 13, minus 2 all over 10x. So what would need to be the least common denominator here? Lucas? 4x squared. So this one just needs an x. This one just needs a 2, and we would go from there. I'm going to not finish that one out. Oh, I never looked at part B. Was this numerator factorable? No. Okay, good. All right. So jump down to the bottom where your denominators are polynomials now. So now it's harder to see what they already have in common, right? Up here you could see, like with the 5x and the 10, the 5 and 10 kind of already had a 5, but this one needed that additional 2. When they're polynomials, you can't tell what they have in common until they're factored. So anytime you're dealing with polynomials, factor first. So that denominator is going to factor into, take out a 5, left with y minus 3. The next denominator is obviously a special pattern, y plus 3 and y minus 3. So they're already a match as far as the y minus 3 is concerned. What does this denominator need that the other one already has? y plus 3. So this one needs a y plus 3. And what does this denominator need that the other one already has? A 5. So this numerator becomes 4y plus 12 over, and yes, this is a long denominator, 5, y minus 3, y plus 3, plus this numerator becomes 25, and you keep, do you guys notice how I'm multiplying out the numerators but not the denominators? I don't need to multiply out the denominators, because once they're common, that common denominator is going to be the denominator of your final answer anyway. Whereas in the numerator, in order to do the addition, I have to multiply it out. So my numerator becomes 4y plus 37. And my denominator is 5, y minus 3, y plus 3. We multiply out our numerators for the sake of having to eventually add them. Since you don't add your denominators, you just keep that same common denominator, whatever it might be, you can leave those alone. Is anything factorable in here? The denominator is already factored. Can the numerator be factored? No, so nothing else is going to cancel. We're good. Okay, jump to C. This one's going to be a little bit different. That's why I put a star next to it. It's already factored on the denominator, right? Whereas if we were doing B, we'd have to factor that, and evaluate what do they already have in common versus what do they need. This one, it's already factored. But what, and if you want to, you can put those in parentheses to see it more clearly. Is it already a common denominator? No. But what do you notice about those two denominators? This is that opposite thing again coming into play. X minus 3 versus 3 minus x. If you want to flip the order of one of them around so that it matches the other, what do you think we have to add into the problem? A negative 1. So if we want to, and I would say, do you prefer x minus 3 or 3 minus x? Right, this order we like, so don't touch this one. This is the one we're going to flip. So we're going to multiply by negative 1 over negative 1. So first fraction, not touching it. In the second fraction, when I multiply my numerator by negative 1, I get a negative 5x plus a 3. And when I multiply my denominator by negative 1, it just really flips the order of subtraction. So rather than 3 minus x, it's now x minus 3. Now we're ready just to add them, right? So what will my numerator be, Jason? Yes. Sorry. I was thinking you'd give me the x term first. If you did negative 4x plus 5, same thing. All over x minus 3. Is anything factorable there? No, so I'm done. So that x minus 3, 3 minus x thing's coming back into play. All right? Keep in mind also, we only wanted to switch one of them. If you switch both of them, they still won't be the same, right? You got too many moving parts. They won't be the same. You just have to change one of them. All right, here's where that conceptual issue is going to come in, okay? Subtraction is a little bit more dangerous, always is with polynomials, because if you're subtracting a polynomial, what do you have to remember to do? Nope, that's dividing. When you're dividing, good try. Distribute. If you are ever, if you're subtracting a whole number, not that big of a deal. When you're adding polynomials, where did we do that? Adding, not a big deal. Because when you distribute a plus sign, doesn't really change a whole lot. But when you're subtracting a polynomial, this is going to be a big deal. So these already have a common denominator because this is the point I'm trying to make with part A. When you are subtracting a polynomial, that has to be in parentheses. So your numerator is going to be 3x plus 7 minus an x minus a positive 3, which will be minus 3. All over x squared minus 4. And then when we combine like terms in the numerator, Jack B, what do I get? What's my numerator? And what's my denominator? Good. Anything factorable? X squared minus 4 becomes x plus 2x minus 2. Good. Anything else? Lucas K, what? Perfect. Did that do anything for us, though? Did that allow anything to be simplified further? Absolutely. X plus 2 and x plus 2 gone. So your final answer is 2 over x minus 2. If you don't distribute that negative, your answer is going to be entirely different. Might not even be factorable. I don't need to see you anymore. Thank you, though. Any questions? Okay. B. We have to start by factoring because we need a common denominator, and they're not already in common. So this denominator becomes what, Eric? When I factor this denominator? Not 4. 2x plus 1, 2x minus 1. Minus 2 over, what's this denominator become, Lucas B? Well, what do I take out in front? 5, and what's left? Plus 1. Good. So, keep going, Lucas B. What do they already have in common? The denominators. 2x plus 1. What does this one need that the other one already has? What does this one need that this one already has? Nope. They both already have the 2x plus 1. That's a wash. That's all set. What else does this one have that this one doesn't? A 5. So this one needs a 5 and a 5. And Lucas B, keep going. What does this one need that this one already has? 2x minus 1. So, when you're distributing 5x minus 15, good. Now, you can do this and condense these fractions all at once here if you want. If you're going to do that, what do you distribute to the 2x minus 1? A negative 2. Negative 4x plus a 2. You could keep it separate as minus and keep it as a separate fraction, 4x minus 2, but then eventually you're going to have to distribute that negative sign anyway. So you can do it all at once, get it over with, and keep this all over your common denominator. And then my numerator just becomes x minus 13 over 2x plus 1, 2x minus 1. Okay? Part C, if I factor these denominators quickly, I get 2 minus x, 2 plus x. And I get x, oh boy, x plus 10, x minus 2. So what, those denominators, Owen, have what in common already? Say it again. Kind of, sort of, right? But is 2 minus x and x minus 2 truly the same thing? No, one of them needs to get switched around, though, right? Which one would you prefer to switch around, the 2 minus x or the x minus 2? Probably the 2 minus x. So in order to switch that around, what do I need to multiply by? Negative 1 over negative 1. Perfect. So now we can consider the negative 1 and the 2 minus x with the x minus 2 to be a wash. So what else does this side need on the left? X plus 10. And what does this side need? 2 plus x. So when I multiply this out, negative 1 times x is just negative x. So I'm going to distribute a negative x. Are you with me there? Negative x times x is negative x squared. Negative x times 10 is negative 10x. What am I going to distribute over to here? A negative 6 would make more sense just to get it all over with at once. So it would be negative 12 and minus 6x. All over. This way it's nice because you only have to write that gross denominator once. This is really going to be my common denominator. I'm not going to write the negative 1 times 2 minus x if I could just write x minus 2. So I have an x plus 10, an x minus 2, and a 2 plus x. So all in all, I've got negative x squared minus 16x minus 12 all over x plus 10, x minus 2, 2 plus x. Is that numerator factorable? 1 and 12, 2 and 6. No, nothing makes 16, so I'm good. Okay, in the last minute, I'm not going to finish this problem, but here's my favorite. This is what people do on this problem that is absolutely a no-no. And I'm sure if I let you guys go on it, you'll have to beat me when it comes around. This is kind of frustrating because they're almost the same. If this one just had a minus 1 attached to it, right? If you subtract 1 from the numerator and subtract 1 from the denominator, is that an equal number? No. Right? If I take like a fraction like 5/10, if I subtract 1 and subtract 1 and I get 4/9, is 4/9 equivalent to 5/10? Absolutely not. So as tempting as that is, you can't just subtract and subtract. That's not the same thing. With fractions, you have to multiply by something over itself. These are actually two totally different denominators. This one needs an x. Don't move. And this one needs an x minus 1. So the common denominator is x minus 1. Do you follow? Okay? Have to multiply by something over itself. You can't just subtract. What